It really feels like our favorite apps and services know us better than we know ourselves sometimes. Well, that is no accident. Today, we're going to pull back the curtain on the hidden force that powers so much of our online world. So yeah, let's get right into it.
What feels like magic is, more often than not, just some really clever technology at work. Let's kick things off with a couple of situations that I'm sure you've experienced yourself.
You know that feeling, right? You get a text alert about some suspicious charge just minutes after it happens. I mean, how on earth does your bank spot that one weird purchase out of literally millions of others? Or think about this. You finish binging a show and bam, the very next recommendation is the perfect film for your mood. It's kind of uncanny, isn't it? How do they get so good at predicting what you'll like?
Well, the secret behind both of those things is a super powerful process called data mining. It's really the engine that turns these massive, messy piles of data into real insights that can spot fraud or guess your next favorite movie.
Okay, so what is data mining, really? Let's break down how we get from just a bunch of raw numbers to something we can actually understand and use.
At its heart, data mining is basically a treasure hunt. It's the process of sifting through absolute mountains of data to find the hidden gems, the valuable patterns and bits of information that just aren't obvious at first glance.
Now, this kind of treasure hunt needs a special kind of treasure chest. See, a regular database just handles day-to-day stuff, but a data warehouse, that's built specifically for this kind of deep analysis. It pulls data from all over the place into one central playground where the real mining can begin.
And the ultimate goal is always to follow this path. You start with data, like a single temperature reading. Then you organize thousands of those readings, maybe into a chart, and suddenly it becomes information. And when you analyze that chart and realize temperatures are rising every year, well, now you have knowledge. And that's the whole point.
But before we can find any of those golden nuggets of knowledge, there's a really critical first step. You can't just dump a bunch of messy data into a program and hope for the best. You've got to prepare it first.
The official roadmap for this whole thing is called the Knowledge Discovery from Data Process, or KDD for short. It's this multi-step journey that takes raw data from all sorts of sources, puts it through a super important cleaning phase, and only then do we get to the mining part to find patterns. And the last step? Making sure those patterns become knowledge we can actually use. And this quote right here, it just nails it. The quality of your insights is totally dependent on the quality of your data. That's why the first, and maybe the most important job, is what we call data preprocessing, which basically just means cleaning everything up. So this prep work really comes down to two main things. First, data cleaning. That's getting rid of weird, inconsistent data and filling in any missing pieces. Second, data integration, which is just combining info from different places into one big, complete dataset. If you get this part right, you're setting yourself up for success.
All right, so our data is clean, it's all in one place, and it's ready to go. Now we get to the really exciting part, the actual mining. Let's look at the core techniques that are used to uncover all those hidden patterns.
First up, we have classification. The easiest way to think about this is just sorting mail. You've already got your bins labeled, bills, personal letters, junk mail, and your job is to put every single piece of mail into the right bin. Simple as that. So to do that sorting, a computer often uses something called a decision tree, which you can see here. It works by asking a series of simple questions, one after another, like, is the person young, or is their income high, to automatically funnel each piece of data into the right category, like Class A or Class B.
Next up is clustering, and this one is a little different. With clustering, you don't have any predefined bins or labels. Instead, the algorithm just looks at all the data and finds natural groupings on its own, based purely on how similar the data points are to each other.
So you can kind of see how it works in this diagram. The whole idea is to group the data points so that everything inside a cluster is really similar, but the clusters themselves are really different from each other. You're basically letting the data itself tell you what the groups are.
Then we have association, which you might have heard of as market basket analysis. This one is all about finding relationships between things. It uncovers rules like, hey, people who buy a computer also buy software about 75% of the time. It's all about finding things that naturally go together.
And finally, there's outlier analysis. This technique kind of does the opposite of clustering. Instead of looking for groups, it looks for the odd one out, the data points that just don't fit in. And yup, this is exactly how your bank spots that fraudulent transaction we talked about right at the beginning. So, we've gone through the techniques, but so what?
Why does any of this actually matter? Let's connect these powerful tools to the impact they have in the real world.
I mean, the applications are just everywhere. In healthcare, it can help spot disease patterns we'd never see otherwise. In finance, it's the front line of defense against fraud. On social media, it's the logic that suggests who you should be friends with. The impact is absolutely massive. This mind map gives you a fantastic bird's-eye view of the entire landscape we've just covered, from cleaning the data all the way to how it's used in the real world. It's a great reminder that even though the process is complex, the results are shaping our lives every single day.
And that brings us to one last, really important question. We've seen the incredible power of data mining, but as it gets even more sophisticated, it forces us to think about a critical trade-off. How do we keep using this to solve huge problems while also making sure we protect our privacy? It's a really big conversation and one we all need to be a part of. Thanks for joining me.